A coordinate system gives us a frame of reference to describe a system we would like to analyze. The two basic systems we will use here are the rectangular or Cartesian coordinate system and the polar coordinate system. In a Cartesian coordinate system, a location can be determined by its x and y coordinates. So here we have the Cartesian coordinates laid out on a y-axis and an x-axis. The center at 0, 0 is the absolute center or origin of this coordinate system. Anything in the upper right will have a positive x and y, and anything in the bottom right will have a positive x and a negative y. Anything in the bottom left quadrant will have a negative x and a negative y, and anything in the upper left quadrant would have a negative x and a positive y. And so any location or spot on this plane can be defined by these coordinates. So here I'm moving this around and you can see that they are both positive. So this location is a x of 6 and a y of 6. If I move it down into these quadrants, you'll notice then the y is negative, and in the lower left, both negative, and up here, x is negative, y is positive. So any spot on this 2D plane can be defined by those coordinates. And as such, any position can be defined by the x, y. The polar coordinate system is an alternative to the Cartesian or ortho system, and it defines its location based on a distance and an angle. So in this case, you can see that we have a location specified by a distance of 7 units away from the origin and at an angle of 60 degrees. So we can move this around, and you'll notice as we increase, obviously 0 to 360, and I can specify another location, again, based on the distance and the angle. And in this case, this angle is measured counterclockwise from that x-axis. It is important to be able to translate from one coordinate system to another. With this illustration, you can see that the relationship between the x, y coordinate system or Cartesian coordinate system and how it relates to the polar coordinate system, which is the r, the distance, and theta at the angle. And as you can see, it is simply just a right triangle geometry that is needed to understand the conversion from one to the other.